So last day, what I said was, in your second problem, you have two equations given: x plus 2y is equal to 4, and 3x minus 2y is equal to 4. These two are the equations. We want to draw straight lines on the graph representing these two algebraic equations. Okay. Now we consider the first equation. Now from one, we first wrote y as a dependent variable. That is why I wrote
Sir,
in terms. Yes,
include
yes,
sir.
yes. Good afternoon. I wrote y in terms of x first. Why I made as the dependent variable, x as the independent variable. Independent variable means it can take any value of your choice, but your choice will not be as independent because your graph paper is of small size. Okay, you have to accommodate points on the graph. So although it is called the independent variable, you're not as independent to take any value of x. You will take only those values of x that you can fit in the graph paper. Okay, in fact, not only x but of y also. Your normal graph paper is, as I told you, the scale that you take. If you take these two scales here, if you take this scale out here, you have 1 centimeter is equal to 1 unit. So if you're in the x-axis, if you see, you have only till 9. Okay, from 0 to 9, and on the y-axis you have from uh, uh, this plus 9 to minus 9. Okay, similarly for your 2 centimeter graph, your your restriction or limitation is, you have only from in the x-axis you have from 0 to, from minus 4 to plus 4, and from the y-axis similarly you have plus 4 to minus 4, or maybe you can write here 5 also. So in at least, so your y you will have a 5 also, and minus 5 also. Okay, so that is not a problem, but you have a certain limitation here. You have bigger limitation in case of if you're taking a bigger scale, but bigger scale is actually more accurate. You should try always to take a bigger scale. Okay, if you can afford to do so according to the equations given. Now mostly in your questions, the scale of the graph will be given. If they are not given, then you use your good judgment to determine which scale should be best. Okay, when you are using your good judgment for to determine which scale to be used, that is where I said that you are not as independent. You have to choose such values which are not fractional, first of all, and secondly, which can be accommodated in the graph paper. Now fractional values sometimes are also acceptable, but especially when you don't have any other option. Okay, but definitely you cannot accept values that you cannot plot. That those values you cannot accept. Okay, fractional values are still acceptable, but we try to avoid as much as possible the fractional values. So we start with the first equation. We write y in terms of x, and we see that I had taken various values of x. Mostly, as I told you, I prefer minus 1, 0, and 1. First I tried minus 1. I got a fractional value. That is why I avoided minus 1. Then I took a 0. So 0, I got a good value here, y is equal to 2, which I can accommodate in the graph paper. So that's, I accepted that value. Next, I took the value minus 1. Minus 1, again, I had got a fractional value. That is, I had got 5 by 2. Y is equal to 5 by 2, which I rejected. So once I have considered minus 1, 0, and 1, now I will move on to the other values. Say minus 2 and plus 2. So I took minus 2 first. I took minus 2 and I got y is equal to 3. So that is also quite acceptable. And for and then I took plus 2 and I got y is equal to 1. Even so, even that is acceptable. So I got three coordinates. The first coordinate was 0 2, second was minus 2 3, and the third was minus 2 1. So I wrote the three coordinates here. Now if you see in the question here, the actually the question tells you that you take a particular scale, that is you take 2 centimeter is equal to 1 unit. So they have mentioned the scale, so you don't have to decide the scale. They have mentioned to you the scale that you have to take. So we 2 centimeter is equal to 1 unit is which graph paper? This is your graph paper for 2 centimeter is equal to 1 unit. Okay, so we shall use this graph paper to plot our points. But before plotting the points, I have taken out the three coordinate for the first equation. We'll take out the three coordinate for the second equation also. So from 2, now we consider the second equation. We have already considered the first equation. Second equation is 3x minus 2y is equal to 4. So write again y in terms of x. So you have 2y is equal to 3x minus 4. And therefore y you get 3x minus 4 divided by 2. This is the value of y that you are getting. Okay, now we shall see what points, what coordinates we get. We have x, we have y. Again, let's start with -1, 0 and 1. For x is equal to -1. Let's see what we get. Y is equal to 3 times -1 minus 4 divided by 2. So we get -3 minus 4 divided by 2, -7 by 2, a fractional value. Okay, so we reject this. So x is equal to -1, we will not consider. Let us consider x is equal to 0. Let's see what we get. So x is equal to 0. You get 3 into 0 minus 4 divided by 2, which is -4 by 2, which is -2. So -2 is quite acceptable. So for x is equal to 0, we are getting y is equal to -2. So this is okay, right? Next, what we do here is we consider x is equal to 1. Okay, so when we consider x is equal to 1, you get y is equal to 3 into 1 minus 4 divided by 2. So you get 3 minus 4 divided by 2, which is again you are getting a fractional value, minus half. So since we want to avoid fractional values, so we reject this value. There are many other values that you can take. Yes, so we take now, we have considered -1, 0 and 1 we have considered. Let us now consider -2. So -6 minus 4 divided by 2, which is -5. So you're getting y is equal to -5. Still acceptable because y ranges, if you see, you can have a +5 here also. So still x is equal to -2 is still acceptable. Okay. So fine, we stick with x is equal to -2. Although in the example, I have not taken this point. Let us take this point here. So x is equal to -2. And for this, you are getting uh, y is equal to -5. Okay. And third one, let's take x is equal to 2. We get 3 into 2 minus 4 divided by 2. 6 minus 4 divided by 2, which is 2 by 2, which is 1. So for x is equal to 2, you are getting y is equal to 1. Okay. So what are the coordinates that you are getting? The coordinates are 0, -2, -2, -5, and you're getting third as 2, 1. So these 3 points you are getting. Let us try to plot these points now. We'll plot this on this graph paper. Okay, so we'll plot this on this graph paper. Fine. So for the first equation, what are the points here? For the first equation, the points are 0, 2. So which one it will be a point 0, 2? 0 and 2. This is 1 point. Okay. You label the point as 0, 2 here. Okay. Next point is -2, 3. -2, 3 will be -2 and +3. So -2, 3 will be a point here. Let's call this -2, 3. Next point is 2, 1. Let's call this 2 and you have a 1 here. So this is 2, 1. So you've got 3 points. Now we can join these points. So with the help of a scale, we join the 3 points. give us a straight line.
Excuse me, sir.
Yes.
Excuse me, sir.
Yes, tell me.
Sir, Shikha is telling to let her enter the.
I'm already letting
Shikha
her
is
enter.
saying that let her enter,
I'm already letting her enter,
but
but I think there's a
she's not
technical
able.
problem. It is her connection problem. I've already let her in.
Okay, sir.
Okay, so this is your straight line. Okay. Um, we have joined the 3 points and we extend, as I told you, you extend till the end of the graph. Okay, as much as possible. So this is your straight line and you label the straight line. What is the equation of the straight line? It is x plus 2y is equal to 4. So you write it here. X plus 2y is equal to 4. This is your straight line. Okay. We draw the next straight line. What are the coordinates here? The coordinates here are these three. 0, minus 2. Let us plot 0, minus 2 first. 0 and minus 2. This is your point 0, minus 2. 0, minus 2. What is the next point here? Minus 2, minus 5. So minus 2 and minus 5. Minus 5 is say somewhere over here. Let us mark it since we don't have here. Minus 5 is here and you have a plus 5 here also. Let us mark these 2 points. So you have minus 2 minus 5 will be a point here. Minus 2 minus 5. Okay, minus 2 minus 5. And the third point is 2 1. 2 1 will be again this point which you have already plotted here. This is your 2. And now we join the 3 points to form a straight line. You extend this point as this straight line as much as possible till the end. Okay, this is a straight line that you are getting, and you label this straight line also. This straight line here is 3x minus 2y is equal to 4. 3x minus 2y is equal to 4. This is your straight line. Okay, and if possible you can give arrowheads here. Okay, because the line will extend till infinity. These arrowheads indicate that lines extend till infinity. Okay, so I've drawn the lines. Fine, the graphing is over. Now let's see the questions. Solve graphically. So first solution, these two lines intersect at which point? 2 1, right? So you'll write the straight lines 1 and 2 intersect at what point? 2 1. Hence the solution of the solution of the simultaneous equations 1 and 2 is given by x is equal to 2 comma y is equal to 1. Okay, so that's answers your first part of the question. Second part is write down the coordinates of the vertices of the triangle formed by these lines. Write down the coordinates of the vertices of the no, not this one. This the question here is write down the area of the triangle formed by the lines and the x-axis. Okay, okay, the lines and the x-axis. So what are the lines and the x-axis? What is the triangle formed here by the lines? This is your line, one line. Okay, this is another line. And which one is your x-axis? This one is your x-axis. So can you see which triangle is formed here? This blue shaded triangle is the triangle formed by the two straight lines and the x-axis. I hope there is no question here. All of you can see the triangle formed by the straight lines and the x-axis. So now let us try to evaluate the area of this. So we are trying to evaluate, let's look at in this graph paper now. We are trying to evaluate the area of this triangle. Okay. How to find out the area? Area of this triangle is half base into height. So let us call these 3 points here as A, B, and C. Let us call these 3 points. Let us call this point A. Instead, let me write here. Let us call this point, I've already called this point A here. This is A, this is B, and this is C. So we want to find out the area of this triangle, ABC. Area of this triangle clearly is half base into height. Now if you see this triangle, let me just do it once again. See this triangle. What is the length here? What is the length of the base? This base is how much? If you see, this is 1 unit, right? 3 to 4. This is 1 unit. So 1 unit, 1 unit. Now the question is, how much is this length? Right? That is the main question. Now that for that you will have to observe how many divisions are there. If you see here, there are 7 divisions here. If you see carefully, there will be 7 divisions. And if you see what is each division here, each division, this is 10 divisions. All this is 10 division, right? And 10 divisions is equal, this is 1 to 2. And in between you have 10 divisions. So how much is one division? 10 divisions is 1 unit. Therefore, how much is one division? One
So
division is,
0.1.
yes, 1 by 10, which is 0.1 unit. And what I see here is that I have 7 divisions here, right? So how much should be the length here? The length should be 7 into 0.1, which is 0.7 units.
7.
0.7 unit. So what is this total length here? 1 unit plus 1 unit plus 0.7 units. So this entire length is actually 2.7 units. Do you agree or not?
Yes, sir.
This should be
Yes, sir.
2.7 units. So base, the length of the base is 2.7 units. Now let's see what the height is. Which one is the height? This one is my height. Okay. And height I see is, how many units is the height? 1 unit. So what should be the area? Half base into height. Half base is how much? 2.7 units. And the height is 1 unit. So this is 2.7 divided by 2, which is 1.35 square units. This is the area of the triangle formed by that straight lines and the x-axis. Any questions? With the length 0.7 units, no questions with that? Okay.
No, sir. No questions.
Then we'll proceed with the next one. We have finished this problem. Now we come to an important problem, actually, this one. Why is it an important problem? Because we learn something here, and we learn something very, very important, which you are going to use later on also. We are going to use later on in class 10, class 12, whatever. You say we are going to use this information here, whatever we are going to observe in this problem. Okay. And let me just remove this. Okay, take 10 centimeter to represent 1 unit on both the axes. Draw the lines x plus 3 is equal to 0. So the lines here are, let's see, x plus 3 is equal to 0. Let us call this number 1. Y minus 2 is equal to 0. Second line. See that the first line does not have a y. Second line does not have an x. Looks strange, but they are very easy to plot. 2x plus 3y is equal to 12 is the third line. Consider the first line. We are going to find points on the first line from 1. Now, whenever you see that an equation does not have an x or does not have a y, for example, in 1, you don't have a y. When you don't have a y, you only find x. So you get x is equal to -3. Okay. So now what can be the points? X, y. See the value of x, there is no y. So value of x does not depend on y. In fact, it does not depend on anything, value of x. So whatever value of y you take, x will remain -3 throughout. Whatever value of y that you can think of, x will remain -3. Is that absolutely clear? Since x does
Yes,
not
sir.
since x does not depend on any other variable or any other thing, x simply is equal to -3. So x will remain -3 whatever value of y you take, whether you take y is equal to minus 23,000 or whether you take minus 1,01,023, whatever value you take, the value of x will remain -3. And since whatever value of y you take, x will remain -3, that means the value of y is up to me. Whatever value I want, I can take, right? So what I do is I take the very simple values of y. I take -0 and 1. Always my choice, my preference. Okay. So I take any three value of y. You can take -2, -1, and -3 also, no problem. Okay. You can take -2, 1, and -5 also, no problem. Whatever value that you can think of y, you can take. But as long as definitely they are not fractional and you can accommodate in your graph paper. My choice will always be a negative value, -1, 0, and 1 positive value. That is always my choice whenever I am given the choice of taking. So look at the second one. The second equation is y -2 is equal to 0. So from here I get y is equal to 2. Okay. Since there is no x, nothing to worry about. So I have my x, I have a y. Okay. Now since y is equal to 2 always, so I'll have always the value of y will always remain 2. Whatever value of x that I take. And again, since I have got my up to me, whatever value I want to take of x, again my choice will always be -1, 0, and 1. Okay. So I've got all the points. So what are the coordinates here? Let me just write. The coordinates are first -3, -1. Next is -3, 0. And next is -3, 1. And here the coordinates are -1, 2, 0, 2, and 1, 2. 3 points we have got. Okay. Now let us consider the third one from 3. In third equation, you have both x and y as usual. 2x plus 3y is equal to 12. Right? Y in terms of x. You write y in terms of x. And now we shall find out the points. Okay, so for various values of x, you take again my preference will be 0, 1, 0, -1, 0, and 1 first. So let's check for x is equal to -1. What is the value of y? 12 minus twice -1 divided by 3. So you have 12 plus 2 divided by 3, which is 14 by 3. Fractional. So I cannot take, let us reject this. Okay. Next, let us take x is equal to 0 now. Y is equal to 12 minus 2 into 0 divided by 3, which is equal to 12 by 3 only, which is 4. So this is acceptable. So for x is equal to 0, we are getting y is equal to 4. 1 point we have got. Okay, let us now try out x is equal to 1. Again, we are getting 10 by 3. which is fractional. So we reject this value. We cannot take. Let us try another values. 2 you can try. You can try -2 also. Let's try -2 first. Again, fractional we are getting 16/3. So no point. Let us try y the x is equal to 2. So 12 minus 4, 8/3. Again a fractional. So we reject 2 also. Try x is equal to 3. Or you can try -3 first also, no problem. So you get what? 6/3. You get 2. That is quite acceptable. So because what is your scale here? They have mentioned 2 centimeter is equal to 1 unit here, right? So you remember that your x and y should not exceed 4. Okay, so for x is equal to 3, you're getting y is equal to 4. Both points 3 and 4 you can accommodate in the 2 centimeter is equal to 1 unit graph. Okay, next let us try x is equal to -3. 12 minus 2 into -3 divided by 3. That's 12 plus 6 divided by 3, which is 6. Although 6 is acceptable, but in 2 centimeter is equal to 1 unit, we will not be able to accept y is equal to 6. Okay, so let us try some other value. Okay, you cannot actually accommodate it in your graph. Y is equal to 6. So let us try x is equal to -4. Y is equal to 12 minus 2 into -4 divided by 3. That's 12 plus 8, 20/3, fractional. No, no point. So let us try x is equal to 4. Y is equal to 12 minus 2 into 4 divided by 3, which is 12 minus 8 divided by 3, which is again fractional you are getting. But the problem is now if you exceed from x is equal to 4, you cannot go to x is equal to 5. So what can you do? What you do is you take this fractional value, because you cannot take x is equal to 5. You cannot go any further. Okay, so you take x is equal to 1.3 approximately you will get. Okay, so let us try to plot this, and it will be easy also to plot this 1.3, because you're taking a big scale. So 1.3 will not be too difficult to plot. Okay, so what are the coordinates here? Let's write it down. The coordinates are right here first. For x is equal to 4, we're getting y is equal to 1.3. So the coordinates are 0, 4, 3, 4, and 4, 1.3. These are the coordinates that you are getting. So let's plot the first line at least, and then maybe I don't think we'll have time to do the second one. But let's at least finish with the first line. In the next class, I will finish with the second line also. Tomorrow and day after, both days you have test, no?
Yes,
Yes,
sir.
sir.
Hmm. So let us see the how the first line works. So you have first line. The points are, there are 3 lines here. So the first line is this. What are the points here? The points here are these: -3, -1. So let us plot -3, -1, -3, -1. This is your point. Let's name this -3, -1. The next point here is -3, 0. So -3 and 0 means here. This is your point. So minus 3, 0. And the third point is minus 3, 1. So I have minus 3 and 1. So this is your point, minus 3, 1. And now you join these 3 points. Okay, excellent. What you are getting here, if you see, what you are getting here is a straight line that is actually parallel to your y-axis, isn't it? This straight line here, what is this straight line? What is the equation of this straight line? X plus 3 is equal to 0, or x is equal to minus 3 also you can say. So let us write x is equal to minus 3. I'll explain why I am writing x is equal to minus 3 here. Okay, x is equal to minus 3. So what you see here is that this straight line x is equal to minus 3 is a straight line that is perpendicular to the x-axis and parallel to the y-axis. Also what you see is that this distance here is 3 units, right? So any straight line, what you understand from this is that any straight line of the form x is equal to minus 3 or x is equal to minus 4 will be a straight line that will be parallel to the y-axis and which will be at a distance of 3 units in the negative direction. Because here is a minus 3, that is why 3 units in the negative direction will be the distance of this straight line from the y-axis. So please remember, x is equal to a represents a straight line parallel to the y-axis and at a distance of a units from the y-axis. Okay, just let me tell you, give you few more examples. If let us take this graph paper once again. If I give you a straight line, say, and I say, what will be the line x is equal to 4? Without even plotting the points, what you can say is that x is equal to 4 will be a straight line that will be parallel to the y-axis and will look something like this, right? At a distance of plus 4 units from the y-axis. So this is your line x is equal to 4. If I tell you if I ask you what should a line like x is equal to minus 3 look like, then you will say x is equal to minus 3 will look like something like this, parallel to the y-axis and at a distance of minus 3 units from the y-axis. Is that absolutely clear, this concept?
Yes, sir.
Okay, go through this concept once again. The time is running out. Okay, I stop here.